Okay guys, let's take a look at our lesson today. We're going to be looking at polar equations of conics. The type that we'll be looking at are all in this particular form right here. All of the ones that we're going to see are in this form. This is a pretty important topic. Actually, this particular topic appears in upper level calculus, like Calculus 3. We don't do the polar form of conics in Cal 2, we just do regular polar equations in Cal 2. But this is a pretty important topic to understand. We have some other guidelines, like yesterday we were looking at guidelines with the rotated conics on, what classifies as a ellipse or parabola or hyperbola. We have a different rule when we are in polar form, and this rule happens to be, basically right here. The eccentricity is located in two different spots in the formula, so we can usually determine what that number is, and the eccentricity will determine what type of conic you'll have. If the eccentricity is 1, you're going to have a parabola. If it's between 0 and 1, an ellipse, and if it's greater than 1, a hyperbola. So there are some exercises where they ask you what type of conic it is, and this is what you would do. You would determine what E is, and then do this test on it. So let's look at there are really 4 different types that we're going to be looking at. And so good news, bad news. The good news is you don't have to memorize these equations. This part right here will be given to you on a quiz or a test that we put these problems on. That little template right there that I've outlined, that's going to be given to you. Now, you're going to have to know how to use it and how to figure out which one is which, but you're not going to have to memorize, these formulas with the directrix. You're not going to have to memorize that. That will be given to you. So let's look at the different forms, kind of determine if we can see some kind of a pattern. All of the conics that we're going to be dealing with will have one focus at the pole, at the origin. All of them will. That's the form that we are working with. We won't work with any other forms. So they all will have a focus at the origin or pole. And this value right here, this D value, which is in the numerator, in all the numerators, multiplied by the E, that D value is going to determine where our, basically, our directrix, the value of our directrix. So let's look at some patterns here. So we have an x equals D directrix and an x equals negative D directrix. Notice those are both vertical lines, and we have cosine in those two formulas. We have a positive cosine and a negative. Again, you're not going to have to memorize the formulas. I just want to show you some patterns. Here we have our directrixes are horizontal, and we have sine. These would be y equal equations, right? And we have sine. These would be x equal equations. We have cosine. Those kind of go together, and whether it's positive or negative determines which side the directrix is on. Notice that when we find the directrix, we're going to be able to determine where the conic is graphed, because wherever the directrix is, whichever side, notice that the conic is wedged between the directrix and the origin, the pole. It's going to be right inside there. It's going to be equally distanced between the focus and the directrix. Okay, so just kind of keep that in mind as you're working with these equations. That pattern will always follow. If you look at each one of them, whatever the conic happens to be is wedged between the directrix and the focus. Okay, and notice how it's curving around the focus. Each of these little conics are curving around the focus. Alright, these are some guidelines right here. For a parabola, the axis of symmetry is perpendicular to the directrix. That makes pretty much sense. That's how it is normally, isn't it? So if say this is a parabola, its axis of symmetry would be this way, and it's perpendicular to the directrix. That's just pretty standard. For an ellipse, the major axis is perpendicular to the directrix. Now that's pretty important because we normally don't deal with directrix with ellipse, right? Just with parabolas. So that's pretty important. The major axis is perpendicular to the directrix for an ellipse, and the transverse axis is perpendicular to the directrix. So those two things will give us clues when we start to build these equations. All right. Okay. Let's take a look at our first example. Okay, what they want us to do here is to find a polar equation for the parabola that has its focus at the origin. Well, like I said, they're all going to be that way for us. Well, they're all going to have the focus at the origin, but they're just saying that. And whose directrix is the line y equals -6. So, since it's a parabola, we know that e equals 1. That would be just something that you would be expected to know. Those things we're not going to give you. Those what the e values are, those will not be provided to you. Only that part that I outlined will we give you on a quiz or a test. The rest of the stuff we won't. So e is 1 because it's a parabola. Our d value, now here's something pretty important, and this is something that students every year get confused with. Okay? So right up here, this is pretty important. And that is the d value doesn't have a sign. It's not, well, it's actually positive. This negative applies to the formula y equals -d. D is simply just d. It's positive. Okay, I'm hoping that's registering here. It is not, when I write my equation, notice none of these have negatives. Because d is, just because y equals -6 doesn't mean d is -6, because it's not, it's 6. Okay, so that's something we need to make sure we understand. So d is 6. So with that information, since we know that y equals -d, I'm going to scroll up here. We're going to look at our little templates up here. We're going to be able to tell exactly which equation to use. Right here, y equals -d. So again, you don't have to memorize that. You would have that. This is the format of the equation that we're going to have. We're going to have an e value of 1, and our d value is 6. So we should just be able to fill that in and be good to go. All right, so let's do that. Okay, so we're going to fill in that equation. The equation that, I'm just going to rewrite it. The equation that was up there was r equals ed over 1 minus e sine theta. And so we fill in the information that we have. We know that e is 1, d is 6. And that is our equation, r equals 6 over 1 minus sine theta. Okay, so it might be just as simple as figuring out which equation it is and subbing into it. The problems could be just like that. Okay? The next two problems are a little bit more complicated because they're going to be asking for more things. They actually give us an equation, and they want us to, show it's an ellipse, sketch it, do some different things. So let's think about that. First of all, this form that these equations are in up here, notice how they all have a 1 minus or a 1 plus. Period. They're all like that. Now that isn't necessarily the prettiest way to write them. The book doesn't always write them like that with the 1. Like if you'll take a look at this example that we are working on right now, it's got a 10, it's got a 3, which the 3 it can't be a 3, it needs to be a 1. So before I can read E and D off of here, I have to get the equation in the proper form. So what can I do to change the 3 to a 1? What am I on? And again, I can only multiply by the number 1. what do I need to do to change that 3 to a 1? Yeah, I have to multiply by 1/3 over 1/3, right? I mean, I have to. Otherwise, here, I won't have I need a 1 here. Now, there's other ways to do it. That's just what I would do. I would multiply by 1/3 over 1/3. So let's get some room over here. So I would multiply by 1/3 over 1/3. And so that would give us an equation that looks like r equals 10/3 over, that would give me a 1 minus 2/3 cosine theta. Okay, according to the format of our equations, it's in the proper format now. We can read E out of it, right? E is going to be this number right here. And if you look at the guidelines up there, or the rule, what is this going to be? Yeah. E is 2/3, which is less than 1. Show that means prove. That's what I'm working on right now. Show that means prove. We're writing down our proof. It's not a formal proof, but it does mean prove that. E equals 2/3, which is less than 1. Therefore, it's an ellipse. Okay, so we've accomplished the first part of A. Now they want us to sketch the graph. Okay, here's where I would suggest that you do a T-chart. And I really just pretty much work with the quadrantals. 0, pi over 2, pi, 3 pi over 2. You could get more points if you wanted to, but you really don't need them. You shouldn't need them. So just doing just these main points should be sufficient. So what we're going to do, and what I would do, is I would put them back in this equation that's easier to work with, this 10 over 3 minus 2. That's where I would put them. So when theta is 0, cosine of 0 is 1. And so 10 over 3 minus 2 would just give us a 10. Okay, so I put pi over 2 in. Cosine of pi over 2 is 0. That gives me 10/3. I put a 3 pi over 2 in there. Oh, I missed pi. Poor little pi. Let's stick it right in here. If I put pi in here, cosine of pi is -1, so that gives me 10/5, which is 2. And then we have 3 pi over 2. 3 pi over 2, put that in, it's going to give me 10/3. And 2 pi is back to 0, so I really don't need that one. Alright, so let's plot those points. They're just points. I'm going to make this r by 2's because I really don't have enough room to go out to 10. 2, 4, 6, 8, 10. Okay, at 0, we're at 10. At pi over 2, we are at 10 over 3. About there. At pi, we are at 2. And at 3 pi over 2, we are at 10/3. Okay, so is that enough for you to tell where the ellipse is? Right, that's plenty, right? Those are plenty of points to tell where the ellipse is. This is one of the focus points right here because that's the way these work. So we sketch our ellipse. They want us to find the center of the ellipse and the lengths of the major and minor axes. To be honest, I find the stuff off the graph. I find the center off the graph. We really can't get the center out of here, like we can in regular, how with an ellipse in a regular ellipse equation, a rectangular one, we can get the center out of it. We're really not going to be able to do that here. So the best thing to do would be to graph it and just count to the middle. So let's see where that would put the center. Okay, it would put the center at 4, 0. The center is for using angle measure 0. Alright, the length of the major axis is going to be pretty straightforward. We would just count that. That's going to be 12. Minor axis is not so easy. Not so easy. So, what we can do is we can revert back to our formula, our like c squared. Remember that one from when we were in rectangular form? C squared equals a squared minus b squared. We can revert back to that. We can do our eccentricity also. So there's several ways to get c. We could count it. That's one way. C is 4. If we're even right here, c would be 4. If it's not an integer, then what we could do to get c, I'll show you just an alternate way. We know that E equals c over a. That's the formula for eccentricity. We know that our eccentricity, if we solve it for c, because that's what we don't know, so we'd have c equals E times a. So c would be our E, we know from up there is 2/3. Our a is 6. And we get 4 that way also. So you can count it off the graph, because we know that's a focus point. The distance from the center to the focus is c. If it's not that plane, you can use this formula to get your c. And then we can, to find b, we just use our normal ellipse formula, c squared equals a squared minus b squared. So that gives us c squared would be 16. A squared would be 36 minus b squared. So b squared is 20, and b is going to be the square root of 20, or let's see, 4 times 5, so 2 root 5. Now, that's b. Is that the length of the minor axis? Is the length of the minor axis one of the b's? It's 2 of them, because b is the distance between the center and one of the co-vertices. It's not the whole thing. So I would have to multiply this by 2 to get my minor axis. So my minor axis is going to be 2 times 2 root 5, which would be 4 root 5. So my center, my major, and minor axis. Okay, how's that? Is that okay? One more. Does anybody still need this? Okay, last one. It says we have a conic, we have another equation. It's basically similar to the one that we did in that it wants us to show that it's a hyperbola and sketch it. So the first part's the same. So let's do that. Same way we did the other. First of all, we have to get the equation in proper form. So we would multiply by 1/2 over 1/2. And that would give me r equals 6 over 1 plus 2 sine theta. Okay, that's our equation. To find our eccentricity, we can read it right off of the equation. The eccentricity is 2. It's this spot right there. And being 2, which is, so it's 2, which is less than 1, excuse me, greater than 1. Therefore, We just proved that it's a hyperbola. That's the show that. We just did the show that. We showed that it was a hyperbola. That's crazy looking. 2, which is greater than 1, so therefore it's a hyperbola. Okay, sketching, same way we did the other one. I would do a T-chart with the quadrantals, 0, pi over 2, pi, 3 pi over 2. I would sub them in here. Either one is fine. I'm going to go ahead, just for time's sake, and write down the values. When you substitute in, you should get that same thing. So we go over here to our graph and draw it. Okay. So let's see. Our angle measure 0, we're at 6. 1, 2, 3, 4. At angle measure pi over 2, we're at 2. At angle measure pi, we're at 6. And at 3 pi over 2, we are at negative 6. Ah, look at that. We know that one of the focuses is right here. So hopefully we can tell how the hyperbola is going to work out. This is going to curve. They always curve around the focus. So what do you think this point is up here? It's the other piece, isn't it? It's the other piece of the hyperbola. Okay, we sketched it. They want us to sketch the asymptotes, and we can do that by just knowledge of the asymptotes. So the asymptotes will cross at the center. This is the center right here. We just counted it. So find the center. Okay, that's great. The center is, what, pi over 2, 1, 2, 3, 4. And our asymptotes will just come out like that. You don't have to find the equation of the asymptotes. It just wants you to sketch them. Okay, what else? I think we're good. We okay?